Okay, for describing data, we use bar charts, and you can see that bar charts are not continuous here. Okay, this is, for example, an example of birth order of 250 students, and this is percentages, and this is the birth order, middle, oldest, and only youngest. Now, we use bar chart to summarize categorical data. These are the categories: middle, oldest, only, youngest. And we use it to illustrate the differences in percentages. So here you can see that this is 20% and this is 40%. So you can use bar charts for describing categorical data. You can use histogram for describing data, and we also use normal line for checking whether the data is left skewed, right skewed, or normal. Okay, so here difference of histogram and bar chart is that you see that these are not continuous, these are categorical, and here histogram is continuous. There is no blank spaces between these ages here. Okay, so it's the measurement data like the other measurement data like bar chart. We can measure and illustrate them in graphics. So this is also an example of a histogram. You can see that a difference of histogram here of the same age of the students here, 250 students. This is again histogram, and that's the bar chart. Now we have dot plot. We can show our data in dot plot like dots. Each dot represents a variable, a person. Okay, so here this means that there are 3 persons here, and there are 3 people here. There are you can count. Okay, so each dot represents a person. Okay, you can see that the stem and leaf plot, and these are box plot. So these are different ways of illustrating data. And this is another example of box plot. Now you can see that here, now this is the distribution of the male. There is a bigger person here, and there is a smaller person here. And this is called scatter plot. And now if a scatter plot is like this, that is all where the dots, okay, they are not in an order, they are not close to each other, they are far away from each other, we say that there is no relationship between them because they are scattered. Okay, this is the meaning of scatter plots. The closer that they are, this means that they are more related. Yes, here there are correlations, and we know that if a graphic is like this, okay, it means that there is no relation because they are scattered. Okay, so what this means here is that GDP, dollars, and fertility is not related. So 2 variables here, if you see such a graph, okay, if you see such a graph, and if it is asked to you what you can say about GDP, dollars, and fertility, you have to say that they are not related because these dots means that they are not related. And okay, here there is another example, okay, life events and mental, okay, so they are not related here. They are not on a line going upwards or downwards, okay, so they are far away from each other, so they are not in an order, so they are not related. And you can see here an example of histogram. So this is an example of ideology and frequency. And you can see that in a histogram there is no empty spaces between these rectangles here. Okay, let's see the extensions here. Extensions of an XPSS program is .sav. What this means, if you save a program with the name hello, for example, its name will be hello.sav and output is SPV. Okay, so we have also seen what is a population and what is a sample. A sample should be an example of the population. It can not be different. So here there is an example of the fishes. You can see they are all blue fishes here. This cannot be red, for example. It should represent, sample should represent population, and it should be a subset of the population. And here we learned that there are different representations for frequency and number, and these all mean that you count them. For example, in this example, you count measurement 1, how many? So here length 13.1, there is one of them, 1, 2, you count them. And now frequency means how many. This means that between 2 and 4 there is 2, between 4 and 6 there are 3, between 6 and 8 there are 5. And now we can see different representations again. Here we see that these are the line graphs and histograms. And here we can represent them with different symbols. We learned what is range. It is the difference between the largest number and the smallest one. And there are different representations like n means number of measurements, how many, and okay, so we learned what is arithmetic mean. We simply say it mean, median, mode. We learn how to find them. And now this was an example here. So here mode is the value that occurs most often. And we learned that these 3 different examples here. So left skipped, symmetric, right skipped. So left skip means that mode is smaller than median is smaller than mean. Symmetrical or normal distribution means that mode equals to median and that's equal to mean. Right skip means that mode is bigger than median and that's bigger than mean. So this is the distribution of our data. We can represent them. These are called histogram because there are no spaces in between here. And this line, this red line is called normality line. Yes, okay, there is 25th percentile, 5th percentile, or 75th percentile. So Q3 means that 75th percentile. And Q1 means 25th percentile. Range, as we say, is the difference between the highest, the maximum, and the minimum value. Here, that's 300. Wait, here this is the. This is this is interquartile range. Now that's you see that this range between 600 minus 4 is 596. Okay, and these are different examples of graphics. This is an SPSS example. Each row in this program means a person. Each row. So this is one person, this is second person, this is third person, and all the values in a row means all the here all the explanations, okay, about this person. This is person 03. So here this means that person 03, I define it as numeric. This is this is a label does a throat job, for example, and you see that that's ordinal, okay? So these are all about this person 3. So this is all about this person 9. So we define these variables. Okay? This is one person, second person. Okay? This is other person. So these are variables. Here in this page, we have how many variables? We have 44 variables, okay? We have 44 variables. And here, here, let us see, we can check it like that, and we can have descriptive statistics to find out how many. Here, oh, there are lots. You can see, let's do the easier way. So in order to find how many people, we can go to descriptive statistics, we can go to frequencies, okay? And we can find descriptives of these variables here. Okay, I am going to find now how many. These are 459. Okay, once more. Now, this is 202nd person. This is the 219th person. Now, so each one of these means that this means all these are a person, okay? So this 4 is a person, 10 is another person. So each row in this program means that they are different person. These are definition of the variables, okay? These are definitions of the variables. These, we can see that there are 44 variables here, and we can see that there are how many? We can find it from the descriptive statistics to 459. We can save it as SPV, okay? We can save it as SPV. What this means, we can give it any name that we want, okay? We can give it name output 1 or study 1, whatever we want. But the extension is always SPV, whether we write it or we don't write it. We can see it here that automatically the extension is SPV. This means that if you see such a program, it means that it is an output. Okay, it is an output. Let me go here. Now, these are these documents. This is an SPSS data file. Okay, where this is an SPV. Okay, this is an SPV output document. So output documents are in blue like this. The shape is this, and this is an statistic data document. Okay, so here we can have analyzed descriptive statistic frequencies. So as it says here in output, we have frequencies and percentages, okay? These are called frequency percentage tables, okay? We can have, from analyzed descriptive statistic frequencies, we can draw graphics, okay? We can draw graphics and we can find mean, median, mode of this data here, okay? Here, these are the graphics. We can draw histograms and we can draw normal curves on them, okay? So they will appear in a few minutes. Yes, that's so quick. So you see that these are histograms. Okay, these are histograms. And these are normality curves. Okay, this is, for example, right skewed because it goes to the right. And you can find mean, median, and mode of these values. Let me see, because I choose them. Yes, okay, here, mean, median, mode. Okay, so you see that these are the mean, median, mode of this data here. Okay, so from where? Once again, from all analyze, we can have descriptive statistics, and we can find frequencies, percentages, mean, median, mode, and we can draw graphics. In other words, we can describe our data. Okay, that's describing how many. We don't do any analysis until now. We just describe, we show them in graphics in different tables, okay? We can have cross-subs. What is the difference of cross-subs? Cross-subs, you have more than one variable in a table. If you have more than one variable in the table, okay, that means cross-subs. This is does a true job, and this is original, for example. You have more than one variable in a table. Now, in these tables, okay, you have one variable, one data here, one variable here, and you have frequencies and percentages. Now, in cross-subs, you have here two different variables. Once again, original does a true job. Let's do one more cross-subs. In cross-subs, I change this data variable here. I put another one. For example, this. I am just making some examples too. Okay, so here this is another cross-subs. A cross-sub contains two different variables, full of energy and reflective, for example. So it helps you to compare two different variables. Now, for describing data, we use descriptive statistics. And we can deliver non-parametric tests, okay? You can see here non-parametric tests, but when we can deliver non-parametric tests, if the distribution is not normal, and if we have more than, if we don't have enough samples, if our groups are less than 30, okay, and we can have parametric tests. Parametric tests are more reliable tests, and they work with means. You can see different examples of parametric tests. One sample t-test, independent sample t-test, some are independent sample t-test, pair sample t-test, one-way ANOVA. These are examples of powerful good tests. But you cannot apply good tests if you don't have enough data at your hand. You should have at least 30 from each group to apply it. You should have a normal distribution, and then you can apply this more powerful tests. These are called parametric tests. And these non-parametric tests, these are less powerful, but sometimes we have to use them in cases where we cannot find many samples, many variables, okay? So in case that we have few data at our hand, or in rare cases like cancer cases or special diseases, okay? or we use them when the distribution is not normal. Maybe that we have many data at hand. Maybe that we have 6,000 data, okay? We have many data, but if the distribution is not normal, we cannot use parametric test and we use non-parametric test.